Now let's talk about the coefficient of determination. So R, as a reminder, this is called the correlation coefficient. Now R squared is going to be called the coefficient of determination. So we have R and we're going to have R squared. So some things that we should know about R squared. The first thing that it is literally R squared. So what I mean is like if you have R is some number, you square that to get R squared. So just how it's computed. So it is literally R squared. R squared, then, if R is between -1 and 1, you square numbers between -1 and 1, you're going to get numbers between 0 and 1. So R squared is always going to be between 0 and 1. Now, it is often written as a percent. So this makes sense, right? Numbers between 0 and 1, you can easily compute those into percents by moving the decimal place 2 places to the right. Now, what that means as a percent is where things get a little bit tricky. So this is really good things, except the definitions are a little bit weird. So just try to maybe rewatch this for a little while until you really get the definition. So what it means as a percent is that it represents the percent of variation in the y value that is explained by variation in the x value. So it's this explained variation. This explained variation of why do we have different y values. We can explain it, a certain percent of it, because we have different x values. Okay, here, then 1 minus r squared, so basically the opposite. So 1 minus r squared, that's going to be the opposite. So say if r squared is equal to 0.7, then that would be 70%. 1 minus r squared would be 1 minus 0.7, which is 0.3, so that'd be 30%. So 70% of the variation is explained by variation of the x value. The other, as a percent, this is the percent of variation that is unexplained or not explained by variation of the x value. So to understand this, we're saying, why do I have different y values? Why? Well, because some of it is explained because I have different x values. Some of it I can't explain. There's something else taking place here. So let's take a look at two examples. So let's say we have this example of the number of tickets bought. And let's say we're just at a very basic thing where ticket sales are $10 per person. I could ask, why do I have different y values? So y values is the number of money brought in by ticket sales. So let's say we were to do this different times throughout the year. Why do I have different number of ticket sales? Well, how much of that is explained by the number of tickets that was bought? So here, so R in this case, this is a trivial example where R is equal to 1. So let's say there was 100 tickets sold at $5 a piece, there's $500. Let's say at a different time there was 80 tickets sold at $5 a piece, then that would be $400. So why do I have different total amounts? So in this case, R is equal to 1, so this tells me that R squared is also equal to 1. So then as a percent, this is 100%. So what that means is that 100% of the variation of the y value is explained by variation of the x value. So I can explain everything. I can explain everything about the money I brought in entirely by the number of tickets that were bought. Okay. Hopefully that makes sense, right? 100% of it can be explained by that. There's nothing that I can't explain. It just is I get the money in, and then that goes to the ticket sales. Great. Now here, more of a normal example, we don't have things that are perfect relationships like this. So let's look at, say, the height of a middle school versus the weight of a middle schooler. So around middle school, that's when people usually start going through growth spurts. You start to weigh more. You have all these things. But there's not a perfect relationship, right? It's not as, if you are 6 feet, or I guess maybe middle school, maybe if you're like 5 feet tall, you are not always going to weigh the same amount, right? So this would be an example. Maybe R would be 0.9, for instance. Then what this would mean is that R squared in this case would be 0.81, or in other words, this would be 81%. So 81%, what that corresponds to is 81% of the reason, or the way that we can explain why do middle schoolers weigh different amounts. 81% of that reason, of that explanation, is because they have different heights. So remember, the variation of the y value is explained by variation of the x value. So the variation of weights, 81% of it is explained by variations of heights. However, Then what this also means, though, is that we have 19% of the variation in weight is unexplained by variation in height. So in this case now, the 1 minus r squared is a percent. That would be 19%. So this 19% of the variation of why do we have different weights is unexplained. I don't know why. It's not because they're different heights, and that makes sense, right? There's a lot of other factors that are going to impact that besides height. So this would be an example of now where we can see how both of these occur, and hopefully that makes some amount of sense. I think it's a really cool measurement to say, how do you explain different y values? It's cool to say, well, how much of it is explainable by this? We could often call this the independent variable. So that's r squared, that's the coefficient of determination. So again, we'll go through some examples in a different video where we can see how do we phrase this, how do we calculate this, and how do we have some intuition behind these.